Okay, today we are having our third lecture of online CCNA program, which is all about IPv6 Internet Protocol version 6. Because previously we have been working on IPv4, that is a version 4 of Internet Protocol. So before going further, we will see what is our agenda for today's lecture, starting with a IPv6, and then what are the grouping and subnet of IPv6, and in the last we will see how to configure it on our system, on our router, and on our devices as well, and how they are communicated as well. So let's get started. Before going for the introduction about IPv6, let's have a look on why IPv6 is essential and why do we need it. Do we really need it, and what are the basically requirements and what are the reasons behind that IPv6. Okay, first of all, one thing you have been listening, one thing that IPv4 is depleted now, no more IPv4 is available on the universe, and people are hungry for internet. But still, on the other side, we also listen one thing that the internet is working very fine. It's growing day by day. Every day there is a growth of like almost 5% of internet traffic. But how it's all being done? Because there's a one more phenomena of netting. You might have heard a word in network address translation, in which we couple multiple private IPs to a one public IP. Normally, it's like normal your home office or a small office, like where 100 people are sitting in your office, and every people, every person has a unique private IP, and then your gateway has a one public IP, and all the IPs are mapped into that IPs. But definitely, when the need of internet and need of IPs are increasing, especially after 3G, 4G, and 5G testings, and also the IoT. Because in IoT, Internet of Things, every device is to connect with internet. Either it's your uh, cell phone, either it's your curtain, it's your microwave oven, it's your car. Everything is connected to the internet. So when everything is going to be connected with the internet, so everyone needs a unique IP. Here I'm using a word of unique because right now everybody is on the internet having an IP, but it's not unique because mostly, like you can say, for consumer network, like 80% of the network is being run on netting. If you check any ISP, they mostly do one thing that's called netting at any instance. For example, if you take an example of a local service provider, what they really do, they give a unique IP to a user. A user means a device. For example, it could be a 4G modem, it could be a DSL modem, it could be your broadband device, and all the people who are connected with the device is getting the same IP. So if in a home there are 5 people, 5 system or 5 computers, they all are having a single IP. So it's always good to use unique IP. So this is a one major requirement, and the second point is very important. Like the big giants like Google, Facebook, and Microsoft, they are readily working on IPv6 because they are very keen to work on IPv6. And you can imagine one thing that all the big companies like Google, Facebook, and everything, they are having a parallel setup of IPv6. They are pushing IPv6 very rapidly. Okay, so these are the major benefits, or you can say major key points why IPv6 is very important nowadays. Okay, so let's move further. Okay, so what are the benefits of IPv6? Because before going what is IPv6, and we must know what are the benefits. Because before knowing benefit of anything, we cannot go for getting the most information about this thing. For example, IPv6 is not for the broadcast. Now you might think one thing that how the broadcast will occur if we need to communicate with multiple people, how they manage it. So let me remind you one concept. If you remember the OSPF lecture where we used a word multicast, because the OSPF packet has not to be sent to everyone. It has to be sent only to the router which are supported by the OSPF protocol. So this is a one good advantage of IPv6, because when there is a broadcast, there is a chance of issue. So the naming convention is little change. In IPv4 we use point to point, but here we use the word unicast, and the multicast with some improved scalability will define what are these. And one very good phenomenon of anycast. Anycast is something like that, one person to anyone, but requirement of that communication is depending upon some other person. Let me describe in an easy way. For example, if you are sitting in Australia and you open google.com, and I am doing the same thing while sitting in a Pakistan, and somebody is sitting in America and doing the same thing, so the same Google page will be opened. uh, right now we are discussing about google.com. We are not discussing about google.co.com.pk or .jp or something. So same page will be occur. So but the concept behind that transmission is, when I enter google.com, it will bring the data from the my nearest location. If you have listened, heard one word CDN, that is like it will fetch data from the closest CDN. If I'm sitting in Australia and I want data of google.com, so he will bring from Hong Kong or maybe from Thailand or from the Australia. But if I'm sitting in Pakistan, maybe the closest CDN is in Dubai or in Qatar or in something, maybe in some Middle East region. But if I'm sitting in America, definitely that Dubai CDN or the Australia CDN will not respond. It will be responded by the nearest one. Maybe it is in LA or somewhere else. So this is a very good example of IPv6 features. And some good advantages and benefits or features you can say about IPv6 is that it has a very you can say simpler architecture and simpler packets. If you have seen a packet of IPv4, there are multiple fields. Every field is doing a different job. But in IPv6, it's very simpler. We will be looking what are the benefit of these. Actually, the main benefit of having a simpler architecture is to less time to process by the router. The more the size of header, more time will be required by a router to process, because whenever a packet received by the router, initially it has a payload which has a data, and then the traffic. For example, payload of for example 10 bytes, and then data of 100 bytes. So the more time will be consumed on these 10 bytes will be minus from the time processing for the traffic. So if IPv6 has a less number of fields and a simpler header, so it will be processed very fast. And definitely, one thing, that IPv6 is a very large uh, size of address. So there are some summarization and some other benefit. And one key benefit is that it has a feature of QoS. The QoS, quality of service. Because if I give you one example, again the same home example, where you have five laptop connected with a modem, and for example laptop number one is doing a streaming and he is choking the bandwidth. For example, you are having a bandwidth of 100 mbps, and the first user is consuming almost 95% of that bandwidth. So what about the other remaining four laptops? They will be not getting the sufficient speed. Maybe they are sharing between remaining 5 MB. So it's mean there is no quality of service. There are some methods can be implemented, but definitely it's not on the that IPv4 layer. It's on application layer or something like that. But one security and the QoS feature is implemented in IPv6 already. So okay, now what is IPv6? Let's discuss some briefly. For example, one thing, that IPv4 was 32-bit, or I can say 4 octet address. 4 octet means 8 bit per octet. It's mean 8 multiplied by 4 is equal to 32 bit. But IPv6 is basically a address of 128 bit. Yes, I repeat, 128 bits. It means there are 128 one or zeros in your address. That makes 16 hexadecimal, because we will not be writing 010101. We write IPv4 in numerical address, but IPv6 in a hexadecimal. Yes, you got the right, like MAC address. MAC address is basically a hexadecimal address. Hexadecimal means, decimal means simple 0 to 9, and hexa means 6 alphabets from A to F: alpha, beta, gamma, A, B, C, D, E, F, G, H. Sorry, F. A, B, C, D, E, F. So these are the starting from 0 to 9. These are 10, and then 5 alphabets: A, B, C, D, E, F. So your address will be like 20010 delta beta 8. Now normally we use delta and beta just to make it easy to listen, because if I say 0 D B, maybe you listen, D can be pronounced as B and B can be pronounced as D. So normally we use like this. So address, still address is very long. Now I'll tell you one thing, that in IPv4, how many numbers are there? How many possible IP addresses is possible in IPv4 class? For example, 2 to the rest of the power 32. It's almost 6 billion. But when it comes to about IPv6, it's like 2 to the power 128, which is like this. I hope nobody can read this number as of now. But if I compare with analogy, then you can get to know what how big this number is. For example, this is 340 unidecillion, and one unidecillion is like 110 with 36 zeros. Or you can correlate with this: number of grains on Earth is equal to this, like how many number of grains, like number of particles on this Earth of scent on the Earth is equal to that IP. So this IP will not be going to be end till till the end, maybe, because it's a very huge number. And this is 128 bits, means there are the 2 raised to the power 128. So this is a huge number. Even if I heard somewhere, like if one square feet of the world having 6,000 IPs. So these IPs will not be going to be end. For example, we know the area of the world, and we divide this number with the area of the world. So every unit area got 6,000 IPs. So it's very difficult that 1 square foot has 1 square foot of the area is having 6,000 IPs. So still, it's very hard, a large number. Okay, now you might be thinking that, yeah, this is my IP: 0000 colon 000000 colon 000000 colon 00 uh, 01. It's my loopback IP. Like IP4 has a loopback IP of 127.0.0.1, which was very easy to read, and which is very easy to write as well. But for IP6, it's very cumbersome. So yes, you are thinking the right thing. So how to, you can say, shorten this concept? So there are 3 rules which can be used to shorten, or you can say, which will be easy for us. For example, first rule is dropping leading zero. Leading zero means starting zero can be dropped. It's a simple arithmetic law that zero starting zero can be omitted. I will not say like, please give me $2. I will say, give me $2. So starting zero can be omitted. So in this example, 3 falcon eagle 0002 colon 0 1 1 colon 0 Charlie 01, and then so on. So I can write 3 falcon eagle and then 2, because I know 3 zeros can be omitted. And one thing is very important, you might have noticed that in IPv4 we have dot, or in IPv6 it's a colon, because it's deliberately make a colon, so the address can be differentiated. Also, because the MAC address is having the same concept of hexadecimal. So just to make a differentiation, they use a colon. Okay. The second rule is that the group of four zeros can be replaced with one zero. This is again the same rules of one rule of arithmetic. Then if you have multiple zeros, you can write one single zero. For example, the same example, three falcon falcon eagle double zero double zero. So I can write single zero over here. And in the second part, I remove the starting leading zero, which is zero triple one, and I write triple one only. So in this example, my both rules will be applicable. So you can see the large uh, long string of IPv6 is shortened to this extent. I know it's very long. Like for example, mm, maybe it's shortened to 20%. Now further move to the third row. If there's a contiguous group of zeros, it can be replaced with double colon. If you have a like in the example of loopback address where you have a contiguous group of zeros like zero zeros and then again zero zero, then you can remove that group by double colon. But there's a catch. This double colon will be used only once. You cannot use it twice. Now, why it is not possible to use twice? But it's a good trick to remove, because if we would have used double colon two times, then when the other person who is decoding or the router who is re-decoding, he will be confused where to put double zeros. For example, in this example, I can see three falcon falcon eagle double zero colon double zero then zeros Charlie zero one. So I remove these eight zeros with a double colon, and then simple zero Charlie zero one. I write Charlie zero one. But if I had the again double zero over here, I should not be using that double colon over here. So I hope these three rules are very clear to you. And if it is not clear, you can ask me. Yes, are we good to go?
Yeah, we good. But the eight zeros can be replaced by one time only, right? If there is
It it
another
is.
set, cannot, right?
Yeah, you are right. It could not be
Okay.
like only 80. It could be 16 zeros. Like if you see the example of loopback zero, loopback address, where you have a seven group of zeros, you replace
Okay.
with only double colon. If you see
Okay.
the example on this picture, black picture, initially you have a seven group of zeros. You make every zeros with a single zero, and then single zeros are contiguous, so you remove it by the double colon.
Okay.
Okay, this is the one example which is taken from my laptop. You can check if IPv6 is enabled on your laptop, you can ping definitely loopback address of IPv6 on your laptop. So either you ping whole address double zero colon double zero and then press enter, or you can write ping double colon one. You can easily check on your laptop it is enabled. But if you have a Windows 7, after Windows 7, normally IPv6 is enabled by default. So you can check if it is easily ping. And definitely there one more address you can ping. We will like Google IPv6 address of Google you can ping, of course. So we will check that later as well. Okay, now how much is the growth? That could question maybe arise in your mind. Like normally, like is 30% of the internet is on IPv6, and these are some countries which are more focusing IPv6 right now. So this is the current status you can say. Actually, it's the last year's update, but right now it's around 30%. Okay, what are the address type which we were discussing in our initial slide? In IPv6, we don't use point-to-point, multi-point, or something like that. We use unicast address. It's same like point-to-point. Like my packet is going to your to one interface that is unicast. Maybe a PC is communicating with a router, or a router is communicating with another router, or a PC is connected with another PC. It's a simple unicast strategy. You know that. And the multicast is this same like normal multicast, but here that group has to be supported by the IPv6 protocol as well. It's been a group of system or router or any which are having IPv6 enabled on their system. So I'm communicating with them. It's mean I'm multicasting to them. The very one good example of multicast, if I can share you, like you have seen IPTV, like TV on your local line. What they do, they make a server. They don't, and which has an IP. For example, ABC is the IP of that server, which is hosting all the channels. So every customer or every user or every DSL modem is multicasting. So they are communicating with only these modems which are IPv6 IPTV enabled. So this is one example of multicasting. Acha, anycasting I have already described you in the initial slide. Like a packet is delivered to the nearest multiple interface. Like same, I have a company with like 70 branches, and I'm using every branch as my backup. So the user coming to my branch and which is the nearest to that location will be served by the that location. For example, this is one common example. For example, you call a company to deliver food at your house. So they will deliver from the nearest location of their franchise. They will not be sending every item to from their head office. So this is like example from the common life. Okay, there are some type of addresses. For example, I tell you about loopback address. This is simple one. One is loopback address of IPv6. But what is a slash mask? In IPv4, the maximum subnet mask is slash 32, because maximum number of bit is 32, but here the maximum number of bit is 128. So definitely the loopback address subnet mask will be 128. That is for sure. Okay, and there are two types of addresses in IPv4: public address and a private address. What are the difference? The public IP or the public address is routable to the internet, but on the other side, private address is not routable to the internet. In IPv6, the concept is same. The global unicast is the address which is globally available, or you can say it's simple public address of IPv6. That is very clear. Okay. Now there are three more addresses. Multicast address is same, which we have learned in IPv4, so you don't need to be worried about that. There are two more addresses: link local and unique local address. Every IPv6 enabled device is having a one IP. Either it is going to internet or not going to internet. It's having any communication, either their ISP is down, whatever. If your laptop or your laptop internet device or your router, your switch or anything which is IPv6 enabled, he must have a unique local address. I can see on my system as well. If you open the command line of your system, if you are having a Windows or if you have a Linux, if you open the terminal and you write ipconfig, then you will see a unique local address of IPv6, which would be starting from FC00. You might be having a long chain of address. Mostly people think that it's a MAC address, but definitely it's IPv6 address. And then there is a link local which is to be connected, which could be described like private address of IPv6. Now we will describe each of them in further slides. Let's start it with that slide. The global unicast, I have already told you, it's like public IP of IPv4, IPv6. Normally it is start with 2001. If you open your browser and check IPv6, you can find this is the address which is assigned by the IANA or your APNIC if you are in Asia Pacific, or if it is in US, it's a RIP. So there are some authorities which are responsible for managing IP pools to every ISP. Okay, then I told you about the link local, which is only used to communicate between devices. For example, my laptop is connected with my router, which is locally available. So when my link is up, they will be generating an IP which start with Falcon Eagle 80. So which would be like your local address, which could not be going to apart from your network. And then definitely a loopback address, which is only reside to your network, even it is not going outside your link, your NIC card, your LAN card. And then a unique address, unique local. Unique local is like private address of IPv4, and it start with Falcon Charlie FC, and then going. So if I describe you in a chart, like global unicast is the address which is available to the internet, then a unique local which is available to you and your peer, and link local is like only site to you, and then of course a loopback address. So these are three main types, and definitely loopback you already know loopback address or self address. And sometime you notice in IPv4 you might get an IP169 something something something. This is the IP when your DSCP fail. You are not able to communicate with your DSCP server. Then they assign a random, or you can say a pseudo IP to you, just to check your NIC card is up. So normally you in IPv4 you have three addresses: public addresses, private address, and a loopback address. But in IPv6 you are having a six IPs: global unicast, which is like same with public IP of IPv6, and then link local is just between to communicate between the local links. For example, my laptop and my gateway, and then loopback address you already knew, and then unspecified address which is same like 169 of IPv4, and then unique local. Every private address of IPv6 is IPv6 is unique local, and then definitely a unicast address which is used uh, for your communicating with single item. Okay, in the initial slides of benefits of IPv6, we discussed one thing, that IPv6 is very easy and very simple architecture, or you can say simple header. So having a simple header makes the communication faster. But there is one thing very important about QoS. So you can see after version there is a field of traffic class. Its mean traffic can be classified according to their need. For example, I am transporting IPv6 for my voice traffic and for my internet traffic, but I want my voice traffic to be on priority side. So definitely I will put a traffic classifier as a one for that voice traffic, and remaining traffic will be considered as a backup. So if link is choked, then the voice traffic will not be disturbed, and data traffic can be disturbed. But on the other side, you can see IPv4 header is very rich in the fields. They have multiple processes and like time to live, how many routers are passed, header is okay, total length, how what is the type of service is flowing, what is the version. Definitely the size of header is big because the size of address is big, but the fields are very limited, and the fields are very only required field are added. So it will take less time for a router to process a IPv6 packet as compared to the IPv4 packet. So one thing maybe rightly in your mind, that how IPv6 is working when our mostly 70% is network is on internet is on IPv4, and why people are running IPv6, how they are both are running together, or maybe there is a parallel world like IPv4 internet is different, IPv6 internet is different, or how they are working. So here is the answer for all your three questions. Actually, all three examples solutions are available. Some people they are companies, they are making a two parallel universe. For example, they are having a one setup of IPv6 and one setup of IPv4. If their user is IPv6 enabled, then they route their traffic toward IPv6 cloud, and if their user are traditional ones, they use IPv4. And some companies are using tunneling. Tunneling is same like we heard about like VPNs or something. Like you want to communicate, like you are having IPv6 network, and remaining world is IPv4. So they make tunnel between, or you can say a logical path between your two clouds which are IPv6 enabled, or the vice versa. And some companies are also using a translation. Like in the initial, I discussed you one solution about netting. In netting, what we do, all our private IPv4 addresses are mapped on a single IPv4 of public IP. So the basic concept is that these are three solutions which are being used rightly in this world right now. Maybe in future time we will be having more traffic of IPv6, then the ISPs will shift IPv6 to the local end as well, because right now most of the companies, they are running IPv6 on their core layer and maybe on the aggregation layer, but not on the access layer, because the customer or the end devices are not IPv6 uh, learned, because they are capable but they are not learning or they are not using that IPv6. So definitely the ISPs or the providers are using IPv6 on the core layer and some part of aggregation layer, but not on the access, or you can say the end user layer. So here I would stop for a while and we'll be taking some question if you